Hello everyone, welcome back to the channel. Today we're going to analyze a full wave center tapped rectifier, both theoretically and practically. This circuit converts AC voltage into pulsating DC voltage using two diodes and a center tapped transformer. During the positive half cycle, the upper diode becomes forward biased and transfers current to the load resistor. During the negative half cycle, the lower diode conducts and current flows through the load resistor again. So the output still remains positive, even during the negative input cycle. Because both half cycles are used, the output frequency becomes twice the input frequency. A 50 Hz AC input becomes a 100 Hz pulsating DC output. Now let's analyze the circuit theoretically. The transformer input is 220 volts RMS at 50 Hz. We use an 18:1 transformer ratio. The secondary peak voltage is equal to 17.2 volts. The average DC output voltage is approximately 11 volts. After considering the diode voltage drop, the final DC voltage becomes approximately 10.3 volts. If the load resistor is 1 kiloohm, the output current will be around 11 milliamps. The peak inverse voltage, or PIV, is equal to 34.4 volts. According to the 1N4001 datasheet, the maximum repetitive reverse voltage is 50 volts. Since 50 volts is greater than 34.4 volts, the diode is suitable for this circuit. The diode current rating is 1 ampere, which is much higher than the required 11 milliamps. So the selected diode can safely operate in this rectifier circuit. Now let's test the circuit practically. We use two 1N4001 diodes, a 1 kiloohm resistor, a breadboard, and a 12012 center tapped transformer. After assembling the circuit, we measure the output voltage using a multimeter. One major advantage of the center-tapped full-wave rectifier is its higher efficiency compared to half-wave rectifiers. It also provides a higher average DC output voltage. The doubled output frequency helps reduce ripple in the output waveform. One disadvantage is the requirement for a center-tapped transformer. Each diode must also tolerate a relatively high reverse voltage. Compared to bridge rectifiers, transformer utilization is lower. The practical measurements are very close to the theoretical calculations. thank you for watching this video. I hope this practical and theoretical analysis was useful for you. If you enjoyed this video, please like, subscribe, and turn on the notification bell for more electronics videos.